Okay, this is lesson 3.8, linear and quadratic systems. The way we can look to see how lines and parabolas intersect is, well, we can graph the line and the parabola and look graphically to see where they cross. And if we were to do that, we could see that they could potentially line up in three different ways. The first way is that we could have a line that never crosses the parabola. So we've got our parabola here above the line. Alternatively, we could have our parabola below the line opening down. Another way parabolas and lines could intersect in a system is they could cross once. And that's when that's when a line is tangent to a curve, which means that it only touches once. And you can see right there, that dot, that's the point where it touches. Alternatively, we could have it cross the parabola and touch twice, which creates three different outcomes. The first are where there's no real roots, so there's no points of intersection. The second is where there's one real root, or one point of intersection. And the last is where there are two real roots, or 2 points of intersection. And believe it or not, we've kind of already done this. We have looked to see where a parabola crosses a line. It's just the line we used last time was the x-axis. We looked to see how many roots there were when y was set to 0. And that's basically like looking at where a parabola crosses the line y equals 0. And the strategies we used for that was factoring to find the roots, which in turn were the zeros or x-intercepts, or using the quadratic formula. And believe it or not, solving a system of a line and a parabola is done the exact same way. In fact, you can actually use the discriminant as well to determine how many solutions there are going to be. And the rules are the exact same. For no real roots, you're going to get a discriminant that's less than 0, a negative discriminant. For one solution, you're going to get a discriminant that equals 0. And for two solutions, you're going to get a discriminant that's greater than 0. Now, what equation are we using to get the values to plug into the discriminant? Well, it's not just the parabola and it's not just the line, it's actually them both together. And what do I mean by that? Well, if you want to determine the points of intersection of a line and a quadratic, so linear and a quadratic, you set the functions equal. You say, where does the line in this case, equal the parabola? And if you rearrange all the terms so they're on one side and you have it set equal to 0, then you will end up with a quadratic equation that represents the solution set. And what that means is you have a quadratic that doesn't represent just the original parabola or just the line. You have information that represents the solution. And if you were to solve it, you would find where they cross. In fact, if you use the quadratic formula on it, you could find where they cross, or you could factor it if it's factorable. But same rules apply. We can use the discriminant to see how many solutions there are. So you'll get two types of questions. I'll give you a line and a parabola, and I'll ask you how many points of intersection there are. And if that's the question, you can use the discriminant after equating them and rearranging. If I ask for the coordinates of where they cross, you'll set them equal, rearrange, but instead of using the discriminant, you'll find the roots. And the way you'll do that is by using factoring or the quadratic formula. So we'll work through both of those scenarios. Let's give it a shot. Here we have a quadratic function, 2x squared minus 2x plus 1, and it asks to determine whether a line, 3x minus 5, will intersect once, twice, or not at all. And so what they're asking is they're asking how many times it crosses. So they're asking us to use the discriminant. Well, what are we using the discriminant on? First, we set the parabola and the line equal. So we say f of x equals g of x. F of x is 2x squared minus 2x plus 1. And g of x is 3x minus 5. That's all on the screen there, perfect. And we move all the terms to one side. So we subtract 3x from both sides. Gives us minus 5x. And we add 5 to both sides, which gives us 6. And now we have over here a quadratic set equal to 0. And our lesson 3.6 or 3.5? I've lost track. One of our previous lessons, we solved quadratics, and now we're at a point where we could solve it. Our last lesson showed us that we could use the discriminant to find out how many solutions there are, and that's what we're going to do. We're going to use the discriminant. So we've got a A, which is 2, a B, which is -5, and a C, which is 6. So we can use the discriminant. The discriminant is B squared minus 4AC. So that's -5 squared minus 4 times 2 times 6. -5 squared is 25. 4 times 2 is 8 times 6 is 48, and it's negative 48. And 25 subtract 48 is -23. So our discriminant is negative. So we can say, since the discriminant is less than 0, f of x and g of x have no, question says, intersect once, twice, or not at all, no point of intersection. Oh, off the screen there. No point of intersection. You could also say that there is no solution, or g of x does not cross f of x. Many ways to make your conclusion there. Okay, so how many times will they cross? Set them equal, isolate for 0, say 0 equals, and use the discriminant. Example 2 says determine the coordinates of the points of intersection of the linear quadratic system. So similar process to start. We're going to set them equal to each other. F of x equals g of x. F of x is my line. Let's move it all the way over here. 0.24x plus 7.2, and g of x is my parabola, 4.8. To really squeeze that in, 4.8x. And now we move all terms to one side. We usually move to the quadratic side. It's up to you which way you move it. I actually like to move it in a direction that would make the x squared term positive. So if we move all the terms to the left, we can accomplish that. So 0.48x squared. Might be a little tight for space here. Let's see what we can do. Moving plus 4.8x to this side makes it minus 4.8. So negative 4.8 plus 0.24. It's mental math here. Negative 4.56x. And the 7.2 can stay. My equal signs aren't going to line up. 7.2 equals 0. And now we have a quadratic. One thing we could do here is we could common factor the 0.48 away and make that our a, and then see if it's factorable. Or we could just plug this into the quadratic formula. I'm going to do that step. I'm going to divide away and common factor here and see if it makes the numbers any nicer. 0.48 from each of the terms leaves me with x squared. If I divide 4.56 by 0.48, I get negative 9.5x, which is kind of nice. And 7.2 divided by 0.48 gives me 15. And now I could look to see if I can factor this. And since we have a decimal, it might imply that we can't factor it. But sometimes you never know. You might be able to figure it out. So let's see. Numbers that multiply to 15 and add to negative 9.5. So 15 and 1, or sorry, negative 15 and negative 1 would add to negative 16. Half of 15 is 7.5, so negative 2 and negative 7.5. Hey, that does add to negative 9.5. So we could factor this and get two decimal answers. odds are you're not going to realize to do that, so you might end up using the quadratic formula. In fact, you'd probably end up using the quadratic formula back here. It's up to you what values you use for your a, b, and c. You could use a, b, and c, or you could common factor, and that would make your a 1, your b negative 9.5, and your c 15. You could use either of those sets of a, b, c, and you would get the exact same answers from the quadratic formula. It's just you have to do a little bit more work when you're working with the decimals. So even though it's factorable, I'll show you the quadratic formula step, but I'm going to use the a, b, and c from here. So for a, I'm going to use 1 because the coefficient on x squared is 1. For b, I'm going to use negative 9.5. And for c, I'm going to use 15. So let's use quadratic formula, even though we know it's factorable. The quadratic formula is negative b plus or minus. So negative 9.5 would just be 9.5. Square root. And underneath the square root sign we have b squared, which would be negative 9.5 squared minus 4 times a times c. And that whole thing is divided by 2 times a. And now we can do a little bit of math here. 9.5 plus or minus the square root of negative 9.5 squared minus 4 times 1 times 15 is 30.25. And that's under the square root. We're going to divide that whole thing by 2. And if I do this once with a plus, 9.5 plus 30.52 divided by 2, and 9.5 minus 30.52, sorry, square root of 30.52 divided by 2, I'll get two different x's. And I call them x1 and x2. And we're not going to use exact value. Or sorry, well, we are going to end up using exact value because we kind of spoiled what those x's are going to be when we factored it. But in the case of finding the coordinates, if it doesn't say use exact value, you don't have to use radicals. And plus, we've already got a decimal underneath our root, so that kind of defeated the purpose. But approximate answers are okay in this situation. So if I do the 9.5 plus the square root of 30.25 divided by 2, I get 7.5. And if I do it with subtract, I get 2. So those are my two x's. But the question didn't say find the solutions, it said find the coordinates of the point of intersection. And these are the x values of where the coordinates would be. But for a coordinate, we need an x and a y. So we have to find a way to get the y value of these two coordinates, because 7.5 comma 2 is not a point. But 7.5 comma something and 2 comma something are the coordinates of our points of intersection. So to get the y value, we just plug our values into either the line or the parabola. And the line is easier because there's less math required. So to find the first coordinate, I'm going to take 7.5 and put it into function f. And if I evaluate this out in a calculator, I get 9. So since the function at 7.5 is 9, one of the POIs is 7.5 comma 9. And we can do the same thing with 2. And if I evaluate this one out, I get 7.68. So therefore, the POIs are 7.5 comma 9 and 2 comma 7.68. Oh, ran out of room there. So 2 points of intersection. Let's recap. How did we do this? Well, we set the functions equal to each other, moved all the terms to one side, and then used the quadratic formula. Alternatively, we considered that we could common factor a out and then see if we could factor what we're left with, and we could, so we could have factored. But if we didn't recognize we could just use quadratic formula. From the quadratic, we get 2x's, so that's going to lead to 2 points of intersection. To find the coordinates, we put each of those x's into the equation of the line, got our 2 y's, and wrote them as points. So, very common question that you're definitely going to see as a part of your test. In fact, I have another one that you can do for practice in the lesson, and it's more of an application. So I'll set it up, and then you can pause the video and try it. Alternatively, you can just pick up with the video, keep moving through, and then try to solve it after. It says, a parachutist jumps from an airplane and immediately opens his parachute. His altitude y in meters after t seconds is modeled by the equation y equals negative 4t plus 300. So here's our first parachutist. A second parachutist jumps 5 seconds later and free falls for a few seconds. Her altitude in meters during this time is modeled by the equation y equals negative 4.9 times t minus 5 squared plus 300. When does she catch up to the first parachutist? So in the context of this question, our first parachutist is this line, and our second parachutist starts at 5 seconds up here and then goes down. Where you have to be careful is that this whole parabola isn't part of the question. We want to find out where they meet or where they catch up, and that would be this point of intersection. They meet here. They also meet here, but in the context of the question, this solution doesn't make sense because this second, the parabolic parachutist, the one following the parabola, doesn't start till 5 seconds, which is right here. So this graph should only exist from here to here. So we can use the equation, which will lead us to find 2 solutions, but only one of the solutions makes sense. It's the one after 5 seconds. So you'll do the question the same way, set them equal, isolate for t by either expanding, collecting like terms and factoring, or using the quadratic formula. Once you get your x value, in this case your t value, you can plug it into either the line or the parabola to find the height or the y value. That's how we can solve 3. So you can try 3 on your own. Again, like I said, try it now, pause the video, or wait till after the video. Try it, and then check your solutions on the course website. We're going to pick up with 2 more examples. Example 4. What is the equation of a tangent with a slope of 4 to the quadratic function y equals 1/2 x squared plus 2x minus 8? So there's a lot of information in this question. The first piece of information is when you see this word tangent, that means line touches once. And when you see something that says the line touches the parabola once, that means, therefore, the discriminant will equal 0. And we're going to use this information to solve our equation. Also, tangent means line. So when you see tangent, the equation of the line is going to be y equals mx plus b. So, what do we know? Well, about the tangent, we know y equals mx plus b. Well, they tell us that the slope is 4. The slope is m, so we know 4x plus b. We don't know what b is. And about the quadratic, we know y equals 1/2 x squared plus 2x minus 8. We know the whole equation of the quadratic. So let's start finishing this question the same way we would have finished either of the first 2 questions. When we were asked for how many solutions there were, we set them equal and isolated all terms on one side. When we were trying to solve, we set them equal and we isolated for all terms on one side. So let's do the same in this question and see where we're at. We've got quadratic equal to tangent. So we've got 1/2 x squared plus 2x minus 8 equal to 4x plus b. And now we're going to move all of our terms to one side. If we do that, we get 1/2 x squared. 2x minus 4x is negative 2x. Negative 8 stays, and b moves to negative b. And now we've got an equation. 1/2 x squared minus 2x minus 8 minus b. And if you don't want to work with fractions, one thing you can do is you can multiply this entire equation by 2. So double every term. That would make this x squared. This would make this minus 4x. Negative 16, negative 2b equals to 0. And you can do that mathematically because the equation is still equal. Multiplying by a constant is something you're allowed to do to make stuff easier. We could also divide if we wanted to, but since we have a half, we definitely don't want to divide. So I'm going to do it to make our math a little bit easier. You don't have to. X squared minus 4x minus 16 minus 2b equals 0. And now we have a quadratic, but we've got something weird going on here at the end. The negative 16 minus 2b. We don't know what b is. But b is whatever the y-intercept of the tangent was. We don't know what the y-intercept was, so we had to say b. But we do know that it would just be a number, like 5. Say it was 5. We don't know it's 5, but say it was 5. Then this term at the end would just be minus 2 times 5, which would be minus 10, and this last term would be negative 26. So what I'm trying to say is this last term right here, it just represents the constant that we don't know. It represents the c, where our a would be 1 and our b would be negative 4. The last terms are c. So we have a quadratic in standard form, an a, b, and a c. We know that the discriminant needs to equal 0. So let's use that information. We know that b squared minus 4ac has to be 0. Well, we know what a, b, and c are, so let's plug that in. b is negative 4, so we've got negative 4 squared. And a is 1. C is the thing that's a little complicated. It's negative 16 minus 2b. But we know that whole thing needs to equal 0. And now what we have here is just a bunch of numbers with a single letter. When you have an equation with numbers and letters, and there's just a single letter, you can solve for that letter. Solving for that letter, that b, gives us the b of our tangent, which helps us answer the question, what is the equation of the tangent? We know it's 4x plus b. We can now find out what b is, because we know the discriminant needs to be 0. Why do we know it needs to be 0? Because it says that it's a tangent. Tangent's a line that touches once. The only way that this line touches this parabola once is if b, the y-intercept, is a certain number. What number? We're about to find out. Negative 4 squared is 16. Negative 4 times 1 is negative 4. Negative 4 times negative 16 is 64. And negative 4 times negative 2b is 8b. And now we got to do a little bit of math. 16 times 6, or plus 64 is 80 plus 8b. And if we move the 80 over, we get negative 80. And if we divide by 8, we get b equals negative 10. Once we know b equals negative 10, we can write the equation of the tangent. Therefore, the equation of the tangent is y equals 4x minus 10. And now if we were to graph this line and this parabola, this line would only touch this parabola once. Where? Doesn't matter, because it doesn't ask that. All it asks is what the equation of the line is. Okay, video's been going a little long. Let's look at the next question and then make a decision here. Determine the value of p in f of x equals px squared minus 5x plus 2 that will result in the intersection of this line with the quadratic at 2 points, 1 point, and no points. So I'm going to set this one up. I'm going to do either A, B, or C. This should say A. And then you're going to try B and C on your own. So we want to know where this parabola intersects this line. Setup's the exact same way. Set them equal to each other. F of x equals g of x. F of x is px, see that, px squared minus 5x plus 2 equal to negative 3x plus 4. Move all of our terms and collect like terms. We get px squared. Add 3x to both sides, minus 2x. Subtract 2 from both sides, we get minus 2. Now we have a quadratic. We're going to use the discriminant. What's the discriminant? Well, the discriminant is b squared minus 4ac. Let's plug our values in and get our discriminant. b squared minus 4ac would be negative 2 squared minus 4 times p times negative 2. Negative 2 squared is 4. Negative 4 times negative 2 is 8. Times p is 8p. So our discriminant is 4 plus 8p. For our solution to have 2 points of intersection, the discriminant would have to be greater than 0, which means that 4 plus 8p has to be greater than 0 because we just found out that our discriminant is 4 plus 8p. Now we solve for p. I'm going to move the 4 to the other side. And I'm going to divide both sides by 8. So if p is greater than negative 1/2, we have 2 solutions. I'm going to write that as a statement. Therefore, if p is greater than negative 1/2, f of x and g of x will have 2 POIs. Notice when I was solving my inequality, I didn't move the 8p, make it negative, and divide by a negative. We discussed in class that dividing by a negative would flip the inequality. So just be careful. If you're going to move the 8p, make it negative, and you divide, make sure you flip the inequality, because we do need to end up with the solution p is greater than negative 1/2. Okay? I'll get you to try B and C. And tell me when there would be 1 point and no points of intersection. And that's it for lesson 3.8. And in fact, that's it for the unit 3. Thanks for watching, and I'll see you next unit.